Alright, so I hope I'm recording. I'm having a little bit better luck than what I normally do, so I hope I just didn't jinx myself. We're finding the domain and range given this relation. We have this equation that relates x and y, and every time we're given an equation, to find the domain, we start out in the same way. We always say the domain is a set of all real numbers, excluding any values that cause division by 0, and excluding any values that cause us to take an even root, like a square root or a fourth root of a negative number. Well, when we look at this problem, we do not have any variables in a denominator, so I don't have to worry about values of x that would cause division by 0. We don't have any values that's underneath a square root or a fourth root, so I don't have to worry about that. That means that my domain is a set of all real numbers from negative infinity to positive infinity. So now, to find the range, we go and we look at the graph. I'll always provide you with the graph, but I figured this time that you could go ahead and graph it using that Desmos graphing calculator. So using your laptop, if you go to that desmos.com, you can key in x cubed minus 2x squared minus 3x, and now you might be zoomed in closer or zoomed out farther, but you'll get roughly this picture. Like I say, your picture, if I zoom in, might look like that. Okay. We're interested in the y-coordinates of all the points that are on this graph. We want to describe them using interval notation. Well, we can see that it's going up forever. Even though it's going to the right, it's also going up forever. And even though it's going to the left, that the values are going down forever. Well, so we always write our interval notation a smaller value, comma, a larger value. As we go up through the graph and we look at the graph, there's no holes in the graph. There's no y values that I need to jump over. The graph is smooth and continuous all the way up to here. So my range is all real numbers, from negative infinity all the way up through to positive infinity. So I hope that helps.